Why do we only see one side of the moon? For millennia, this hidden face has fueled all kinds of mystery, speculation, and even conspiracy theories. A side that never turns toward us, always hidden in the shadows of the unknown. But that has changed. For the first time in history, China managed to bring a piece of this secret world to Earth. In June 2024, the Chang'e 6 mission returned with almost 4.3 pounds of rocks and dust from the most enigmatic place in our sky. And what the analysis of this material may reveal promises to be stranger and more important than we imagined. The answers that are coming will not only rewrite the moon's history, but also give us clues about the violent origin of our own planet. To understand the weight of this mission, we first need to comprehend, why does the moon have a hidden side? The cause is a phenomenon called tidal locking. Billions of years ago, Earth's gravity slowed the moon's rotation until the time it takes to spin on its own axis became the same as it takes to orbit around us. The result? It always shows us the same face, like a dance partner who never turns their back. For decades, this other side was a complete mystery. It was only in 1959 that the Soviet Luna 3 probe sent the first grainy images, and what we saw was shocking. The side we know is full of those immense dark plains, the lunar seas, which are ancient solidified lava covering more than 30% of the surface. The hidden side is the opposite, a wild terrain, brutally rugged, covered with craters and almost no seas. It's as if they were two completely different worlds glued together. Later observations only increased the enigma. The crust of the hidden side is significantly thicker, and its chemical composition is different. The question that has tormented scientists since then is, why? Why this dramatic difference? The answer is locked in the rocks of the hidden side, and finding this key serves not only to understand the moon, but to look into the most remote past of Earth itself. And that's where China enters, with its ambitious and methodical lunar exploration program, named in honor of the moon goddess in Chinese mythology, Chang'e. The program advanced step by step. First orbiters, then rovers, and with Chang'e 5, they had already managed to bring samples from the visible side, the first in more than 40 years. But Chang'e 6 had a much bolder mission: to land, collect, and bring back samples from the most difficult and unexplored place on the moon. The complexity of this is immense. Landing on the hidden side means there's no direct communication line with Earth. To solve this problem, China first launched a relay satellite, Kuiqiao-2, and positioned it in a special orbit to function as a constant communication bridge. The landing site wasn't chosen by chance either: the South Pole Aitken Basin. Think of the South Pole Aitken Basin as one of the largest and oldest impact scars in the entire solar system. With a diameter of 1,553 miles, it was formed by a cataclysmic collision more than 4 billion years ago. Scientists believe the impact was so violent that it may have torn material from the lunar mantle, the layer just below the crust. Landing there and collecting samples would be like having the chance to analyze a piece of the moon's deep interior, something that could revolutionize what we know about planet formation. And on June 2, 2024, after almost a month of travel, the Chang'e 6 module touched the lunar surface inside Apollo crater, which is in the South Pole Aitken Basin, marking one of the most impressive feats of modern space engineering. Once on the ground, the probe had no time to lose. Chang'e 6's lander activated its robotic arm and a drill to collect the treasure it went to find. In a period of intensive work, it dug and drilled the regolith, lunar dust, collecting samples both from the surface and from up to 6.6 feet deep. Every gram of this material is a time capsule, a geological record that remained untouched for billions of years. In total, 4.2 pounds of rocks and dust were sealed in a vacuum container. Then, a small module took off from the surface, the first takeoff in history on the hidden side, and met with the orbiter waiting above. After transferring the precious cargo, the capsule began its return journey and landed safely in Inner Mongolia on June 25, 2024. For the first time, humanity had pieces of the moon's hidden side in hand. The Pandora's box of lunar history was about to be opened. Scientists in China and around the world await with enormous expectation. Complete analysis will take months, maybe years, but researchers already have a list of mysteries they hope to finally solve with these samples. The first major question is the composition and texture of the soil. The theory is that the hidden side may have suffered a different type of space weathering, bombardment by solar wind and micrometeoroids, perhaps because it didn't have the partial protection of Earth's magnetic field. If the soil has a distinct composition, this could confirm this idea. Another mystery is volcanism. We know the visible side had active volcanoes for much longer. The rocks from there can tell us how long ago the region had volcanoes and, more importantly, what their chemical fingerprint is. If the lavas from there are poor in certain radioactive elements that are abundant on the visible side, this would be a fundamental clue to understanding why one side of the moon was geologically more active than the other. But perhaps the biggest revelation will come from water, or the lack of it. One of the most important theories suggests that the mantle under the hidden side is much drier than the mantle under the side we see. This water dichotomy may be the missing piece to explain the differences between the two faces. Chang'e 6's samples are our first chance to test this hypothesis directly, measuring the volatiles trapped in the rocks. So what could all this mean? These samples aren't just rocks. They're pieces of a cosmic puzzle that scientists have been trying to assemble for more than 50 years to answer that fundamental question. Why are the two sides of the moon so different? The theory gaining the most strength is that of the mega impact that created the South Pole Aitken Basin. Computer simulations suggest that this colossal collision generated a giant heat wave that spread through the moon's interior. This wave would have pushed radioactive elements, which generate heat, to the opposite side of the impact. That is, to the side that today is visible to us. This concentration of radioactive fuel would have kept the visible side's mantle hotter for longer, resulting in a thinner crust and much more volcanic activity, creating the seas we see from Earth. The hidden side, on the other hand, would have been left with fewer of these elements, cooled faster, and formed a thicker, more rigid crust that prevented magma from rising. Chang'e 6's samples, with the chemistry they carry, are the proof that can confirm or refute this great story of the moon. They will give us a portrait of a side of the moon that evolved very differently. And this is bigger than the moon. Since our satellite is largely made of material from primitive Earth, studying it is like looking at a fossil of our own planet, perfectly preserved in the vacuum of space. Ultimately, understanding the moon is understanding our own origin. Chang'e 6's success is not just a victory for science. It's a milestone that consolidates China as a space superpower and sets the tone for a new era in lunar exploration. If the U.S. Apollo missions dominated the 20th century, the 21st century is being defined by a race with more players and different strategies. China is not alone. The United States, with the Artemis program, wants to take astronauts back to the moon, including to the South Pole, to try to establish a human presence there. Europe, Russia, India, and even private companies also have ambitious plans. But China seems to be playing a long-term game. With upcoming missions, Chang'e 7 and Chang'e 8, they plan to map resources and test technologies to build a lunar base. The International Lunar Research Station project is proof that they're building the foundations for a lasting presence. Chang'e 6's samples, which will be shared with scientists from other countries, are a gesture of collaboration, but also a demonstration of technological capability that no one can ignore anymore. We are witnessing, in real time, one of the greatest mysteries of our solar system being unraveled. What China brought home is more than rocks. It's the first chapter of a completely new book about the moon's history. If you are also fascinated by this journey and want to stay informed about this new era of exploration, like, subscribe, and share this video so more people know about the secrets the moon still holds. And of course, subscribe to the channel so you don't miss the next discoveries. Chang'e 6's samples are a gift to all humanity. They remind us that even in our closest cosmic neighbor, there are still wild frontiers and deep secrets to be revealed. For the first time, we have the chance to read the moon's history from its most secret chapter. And this story is just beginning to be told. The hidden side is no longer so hidden, and what it will teach us should forever change our vision of the moon, Earth, and our place in the universe.